Hello, welcome to my YouTube channel, Taxonomy Online Mathematics. If you are seeing this for the first time, I will indulge you to subscribe. If you have seen the previous episode, I will say congratulations. We are at the end of the tutorial on the circle theorem. We have done the videos on theorem 1 up to 8. So in this video, we will be treating theorem number 9, 10. So under this, we are having the angle subtended by equal chord. We know a chord is just a line that joins 2 points on a circle. Equal chord, that the angle they subtend at the center is equal or are equal. So typical example is what we are seeing. We can see the line AB is a chord, CD is a chord. This mark here indicates that the two chords are equal of length. Meaning if here is 6 centimeter, this is 6 centimeter. Then if that is true, then it means that the angle both subtend at the center will be equal. The angle both will subtend at the center will be equal. That is one of the theorem. Then another theorem also says that the angle subtended by equal chord at the circumference of a circle are also what? Equal. Simply put, just a continuation of that. So we have theorem number 10. That simply means that if I have a circle that have a chord, AB being equal to the chord CD, the angle that this chord will form here will be the same as the angle that this chord will also form here. So this is equal length of a chord, subtending the angle at the circumference, not at the center. But if it's at the center, the angles formed will be equal. If it's at the circumference, the angle formed will also be what? Equal. So we can translate that in solving question like this. We are asked to find the value of y. Since we are aware that mn is equal to st, meaning the angle here should be the same as the angle y. But we are aware that any line drawn from the center to the circumference is a radius. So this is a radius, while this is also a radius. That makes it that these lines are also equal. That makes that angle, the triangle here, OMT, to become an isosceles triangle. And if that is true, that means the angle here is also what? 56. Then I can find this angle which is the same as this. So I can say that angle MON, which is this angle, is going to be equal to 180 minus 1, 56 plus 56. These two angles are the base angle for an isosceles triangle. So if you add that, you get 112. So 180, 112. So that is going to give us 68 degree. Meaning this angle here is going to be 68. Therefore, the angle we know here, MON, is also equal to the angle what? Y, which is the same as what? 68 degrees. Why? The equal chord sustain equal angle at the what? The center of a circle. So if this is 68, then the y is also what? 68. Alright, I believe you grab the concept. This is the last aspect of the circle theorem, even though we have another theorem who also have this. Now if you have a chord, a radius drawn towards the center of a chord, not passing through, but towards the center, by set the chord into two equal parts. That is also another property. If you have a radius that is moving, or a line from the center, because it doesn't touch the circumference, so we cannot call it a radius. But a line from the center towards our chord, any chord at all, divide the chord into two. And it's also perpendicular to the chord, meaning this will be 90, this will also be what? 90 degrees. we'll be using this also in some questions really to help us solve some certain missing angles. I believe at this point, any question that will come your way under circle theorem or plane geometry 2, based on this theorem that we've discussed, you should be able to tackle those questions with ease. The next episode will be trying to put some past questions together under this. We to take actually 4 or 5 of the theorems in one question. We see how best we can synthesize that to get an answer. If you like the video, please don't forget to subscribe. If you have not, give a thumbs up if you like it. Share with yourself, your colleagues, anybody who may like this, and don't forget to leave a comment for us to get interactive. See you in the next episode as we solve questions on plane geometry 2.